This is Algebra 1, Semester 2. It's the unit on quadratics. It's number 3. And it's lesson number 20, graph to equation of a quadratic practice. So we're going to look at the graph and we're going to try to identify the correct equation from it. It's on creatormath.com under the Algebra tab. Copy the following problems. This has 1 through 14 on it. There's a lot more on the practice set here on this page, but don't do them. Please do 1 through 14. You can do them once you do these. Do these first, and they go in your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. Make sure you know how to find that. Looks like this. You might have to type in creatormath.weebly.com. Here's what the home page looks like. All your notes are under the Algebra tab. Pass by the vocabulary. Find the correct unit. Here's quadratics. Find the correct lesson. All the way down here, graph to equation. Here are the notes. Click on that tab. Might have to load it a couple times. Mine is not loading right now. I'm going to go back and reload it. And I've always gotten it to load by the second, but that doesn't mean you will. So what have we got here? We're just talking about the roots of the parabola, where the y-intercept to, which we've talked about before in other lessons. So we're going to cover it again in this one. We're just looking at, given a graph, can we pick out the correct equation, right? So this one should go pretty quickly because we're going to find the roots, find the y-intercept, and match it up. Here are some recitals. Use the location of the roots or zeros to find the binomials which produce the parabola. Multiply those to find the expression or equation of the quadratic. In this case, it would be equation because to have roots, you've got to put it equal to 0. So I kind of object to that language there. Quadratic, you're going to produce from a FOIL calculation first, outside, inside, last of two binomials. Binomials are two-term expressions. A parabola is the shape produced by a quadratic, which is anything to the any variable to the power 2. We call roots, zeros, and x-intercepts are all the same thing. Roots and zeros kind of have to do with the idea that we have to place the y equal to 0 to find the x-intercepts. Let's see. All right, let's go from here and see what we find. So they're giving us a graph of a parabola. Let's focus on the important parts. Where are my roots? There they are. So looks like there's a root right here. This is -5, this looks like -9. So I'm looking for an x plus 9 in a binomial. This looks like 1, 2, 3. This looks like this root is at 3, so I'm looking for x minus 3. Why do they reverse? Because you had to put these equal to 0, right? You don't need this. You add 3 to both sides. And x equals 3. So a binomial of x minus 3 produces a root of x equals to 3. And why is this the case? Because we must put y equal to 0 to find the roots. And so if you notice, here's the y-axis here. The value of y right here has to be equal to 0 for these 2 points to emerge. So if you have two binomials like x plus 9 times x minus 3, this has to be placed equal to 0 here to go ahead and say that a times b must equal 0 according to the 0 multiplication rule. Then we must test each of these to go to 0 here and to go to 0s here, which is the same thing saying x plus 9 equals 0, which produces x equals -9, and x minus 3 equals 0, which produces x equals 3. So I hope that helps. That's review. We've done it on other lessons up till now. So we're definitely looking for anything. Once I know that this right here, x minus 3, x plus 9, I got it. Also remember that if we put x equal to 0 here and x equal to 0 here, these disappear and you're left with y equals -27. So notice right here the y-intercept is at -27. So I'm sure that this graph produces this one. And just to be complete on this problem set, we're not going to do it on the others. We're going to go a lot faster. If we go to there we go. There's where I'm trying to go. And we type in either of these. Let's type in f of x equals x squared plus 6x minus 27. I'm just going to modify the one that's in there. X squared plus 6x minus 27. All right, so, and we say, can I say home? Will that do it? There we go. And this will show us the same parabola we're looking at. Notice the roots right here at -9 and at 3, and it will show it crossing here at -27, 2, 4, 6, 7, right in the middle there. Good. And you could expand it, click on it, and it will tell you what it is. Right? So -27 is that y-intercept. So you can go back and graph all these too, and it even tells you that in the instruction to go ahead and graph them. But we're just going to look at the graph and pick out the right equation, and it should go pretty quickly looking at the roots and the y-intercept. So here's our parabola. Look, y-intercept way up here. What is this? 42, 4, 6, 8. So anything that's got a plus 48 in it, I already am suspect of this one. None of the others have a plus 48 in that C term there, which is going to define the y-axis. So let's check the roots. Here's one here. 2, 4, 6. It looks like you got an x equal to 6 and an x equal to 8. So that would produce x minus 6 times x minus 8 equal to 0. Right? So right here. So pretty quick. Let's roll to the next. Again, a y-intercept looks like a 48 again. Right? 2, 4. Nope. Does not look like a 48. 2, 4, 6, 8, 10. This is right in the middle of the two. 2, 4, 5. Looks like a 45. All right. It might be a little bit hard to see from this. I apologize. Here it looks like a root, but I'm looking for anything with a 45, and none of these have it. The 48, it's definitely not. So I know it's this answer already. Let's look at the roots. Is there a root at 9 and a root at 5? This looks like 5. This looks like 9. This is my equation. So as long as the graph tells me enough information and I can see it, you guys, if it's too hard to see, then I agree. This becomes difficult. So this looks like a minus 9 maybe. And this looks like a 2, 4, 6, 7, a plus 7. So this would be x minus 7 and an x plus 9. They reverse for the two binomials, which are going to be equal to 0, or f of x that we assign to 0, right? Or y that we assign to 0 in this case, because we're trying to find those roots. So I see x minus 7, x plus 9. That's my target. This is minus 60 right here. Let's just check the tail. Minus 62, 63. Check, check, check. Remember, my answers all come out A. Yours are going to be randomly assigned. So here looks like a single root. Look at this. A single root where this is minus 20, so this is minus 10, but this looks like a little further than this. I would say this is minus 11, which would be x plus 11, and it's got to be squared because there's only one. It has to produce the same one twice, equal to 0. So notice I got right here an x plus 11 squared, and if I look at where this thing's crossing the y-axis, it's all the way up here at 121. So that confirms for me this right here at 121. Those are my equations / my two binomials being multiplied by each other produces. This is up at 121 also. Which one's got a 121? They finally gave us a little bit of a challenge. They gave us 2. But I can get rid of minus 121 and I can get rid of this one. Let's see where the root is. This is 10, so this must be plus 11. So this must be x minus 11 squared. So the one that's x minus 11 is my candidate, my winning candidate, for which equation is produced from the graph, right? And remember, they're both simultaneous expressions of this parabola. One is just graphed, the other is in equation form. So it looks like a minus, here's 10 right here. You guys can't see the grid line maybe. And here's minus 10 and positive 10. This looks like at plus 11. And minus 11. So this looks like x plus 11 times x minus 11 equals 0. So I'm looking for these two binomials. And where does it cross the y-axis? Looks like minus 121. So here's minus 121. Here's my x plus 11, x minus 11. Check. They gave us this one, but this is plus 121. All right, so looks like a y-intercept of 35. This is 32, 4, 6, 8, 10. No, 1, 2, 3, 4, 5. There we go. So this is up 1. So this looks like at a 36. I'm looking for anything with a c value of 36. This one, check. I'm happy with that. But this says x plus 6, and there's two of them being multiplied. Two binomials of x plus 6 being multiplied by each other. So that means my root is going to be at x equal to minus 6. And sure enough, here's minus 5, minus 6. That checks out. And I have one root because these are both identical. There's two of them, right? So, and that would be the discriminant equal to 0, by the way, too, if you're thinking back to the prior lesson. So y-intercept of 15. Anything with a 15, a c equal to 15 here, a tail I call it, there you go. So I'm thinking this already, these are out already, but just to confirm, here's a x equal to negative 5, and x equal to negative 1, 2, 3, x equal to negative 3. So reverse these for the binomial, so x plus 5 times x plus 3 equals 0. So x plus 5, x plus 3. Check. Y-intercept way up here at 40, right? Way up at 40. So I'm looking for anything with plus 40 in that tail position. Sure enough, plus 40 right here. So that already clues me in on this one. And they didn't make it that difficult on us, right? We know what the answer is just based on that piece of data alone. Others, if you're really taking a little bit more complicated multiple choice test here, they would make they would give you all 40s here, right? And then mix these up a little to see if you can find the right one. Well, let's say x equal to 5, that's one root here. 6, 7, 8, x equal to 8, that's the other root. So reverse them for the binomials and put them equal to 0, and x minus 8, x minus 5. Check. All right. Well, this looks like the x-axis right here. Look, 2, 4, 6, 2, 4, 6, 8, 10. This looks like x equal to 7. And it's hard for me to see, so it's probably hard for you to see. 2, 4, 6, 8, 10. This looks like x equal to minus 9. It's not quite to the 10. Here's the 10 right there. So reverse it. X plus 9 times x minus 7 equals 0. Those are your two binomials. So let's see if we can find those. Sure enough, a minus 7 and a plus 9. So I'm happy about this. Can I confirm that it's crossing at negative 63? Here's negative 60. 2, 4. This would be 3. So check. I've got all my points in order, and I can decide which equation is correct based upon the graph. This one's crossing at, let's see, 2, 4, 6, 8, 10. 2, 4, 6, 7. So x equal to a minus 7 is one root. 2, 4, 6, 8, 9. So x equal to a 9 is the other. Nope. I don't like, why am I putting parentheses around these? Stop that. These are where the roots are equal to. Now change it to a binomial. X plus 7. All right, I'm struggling. This one would be x minus 9 equals 0. There we go. Sorry for the sloppiness, you guys. So x plus 7, check. X minus 9, check. And does it cross at minus 62, 3? Sure does, right here. That's our equation, and two binomials being multiplied to produce this. So this parabola opens downward, right? Anything opening downward must have a negative in front of that a term. So none of these others have negatives. So this is a dead giveaway. I already know it's this one based upon the fact it's opening downward. But let's look at the other things. Does it cross the y-axis at a negative 20 and 40, negative 20, negative 30, negative 35? Must be about negative 36. I'm okay with that. How about the roots? Look at these roots right here. Here's 0. Here's 20. That makes this minus 10. Man, these are hard to figure out. This looks like minus 5. I don't know. Minus 6 maybe? Question mark. And how about this one? Minus, I don't know, 1? question mark. So I'm not totally sure, but let's go and check. Let's take this one and say 3x plus 2 equals 0, minus 2 minus 2, 3x equals minus 2, divided by 3, x equals minus 2/3. Okay, so is this at a minus 2/3 right here? Not minus 1, but minus 2/3. Okay, I mean, I can go with that. That's a definite maybe. Let's try the other one. X plus 6 equals 0, minus 6 minus 6, x equals minus 6. So I like that. That was even what I guessed, right? So I'm pretty sure this is it, and they didn't make it difficult on me. They didn't give me a lot of close answers, so I know I've got the right answer in this case. Let's see, where does this cross? All right, here are my roots. This is minus, This must be 1, and this must be 2. Every 2 tick marks is 1. So this is 1 point something. I don't know, 1.25? X equals 1.25 right there, and x equals, if this is 0.5, x equals minus 0.75. I'm doing decimals, so it's probably going to come out a fraction. Where does it cross? It crosses negative 12, 14, 16, negative 15. Anything with a negative 15, I already got the right answer. Let's just look at these roots. 4x plus 3 equals 0, minus 3, minus 3. 4x equals a minus 3 divided by 4 divided by 4. X equals minus 3/4. Ah, look at that. Isn't minus 3/4 equal to a minus 0.75? If you have 3/4 of a dollar, isn't it 75 cents? If you have 3/4, you only have 75 cents, and it's a negative, so minus 75 cents. And sure enough, that's what I said right here, minus 0.75. So I'm happy about that. And I'm going to take this one, 4x minus 5 equals 0, plus 5 on both sides. 4x equals 5, divide by 4 on both sides, and x equals 5/4. 5/4 is, this is a mixed number. Now we can change it to a mixed number here. It's an improper fraction right now. X equals, 4 goes into 5 once, there's 1 left over. So 1 1/4, isn't that also equal to 1.25? If you have a dollar and 1/4, isn't that $1.25? And that's exactly what I thought this lined up as right there. So this is definitely my candidate. All right, and maybe one last thing to show you. I know we plugged in one of these problems into Desmos. Let's do another right here. Let's do 16. Let's put 16. There we go. 16x squared minus 8x, and I'm modifying the one that's already in there. Minus 8x minus 15. And home, so we can find it. There it is. So this is the parabola we're looking at, and notice we can click on the roots and it will tell us 1.25, check, negative 0.75, check, and the location of crossing the y-axis right here, minus 15, check. And just one more thing to show you, if we put in another equation here and we said y equals, which is the same as f of x, we can use y or f of x. We like the function notation for certain reasons, and I'm doing this because I'm lazy. I don't want to type f of x. I'm going to do y equals, and let's put in the two binomials, parentheses 4x minus 5, parentheses times 4x plus 3. 4x plus 3. Okay. Notice two parabolas. Can I turn one off and one on? Okay, one's off. There's the blue one. Let's turn the red one on. It's right on top of it. Turn the blue one off. They're right on top of each other. So just so you understand, this is proving that these are equivalent statements, right? They look different, but they're the same value. I mean, think of having 4/4 or a dollar. Don't you have a dollar in both cases? But they look totally different, right? So you have to become a little bit more sophisticated in math where you can go, wow, these two things look totally different, but they actually produce the exact same graph. Therefore, they are the exact same value in terms of what they represent. Make sure you're on the correct lesson. Algebra Semester 1. It's the unit on quadratics, and it's rather long. It's got at least 20 lessons here because we're on lesson number 20, Graph to Equation of a Quadratic Practice, and it's on creatormath.com under the Algebra tab. You might have to type creatormath.weebly.com into Google to find it. All right? Hope that helps.